Okay, so this is the page that is a video recap of the Amoeba Sisters video that you just took on Ed Puzzle. Okay, so it says vocabulary practice. Fill in the missing boxes, assuming that having hair for guinea pigs follows mandolin inheritance. So excuse me. So what that means is you can use a Punnett square. Okay. Where the H dominant allele codes for hair. So remember that the H is a dominant gene or a dominant allele, and any guinea pig that has the capital H will have hair. So the little h, the lowercase h, codes for lack of hair. So that allele means that it's recessive. So it only shows up in the phenotype if there are two lowercase h's. Okay. So let's take a look. I'm going to do the first one with you as an example, and then you can do the others on your own. Okay. So this one, you can already see that the guinea pig has hair. And we know this is correct because there are two capital H's, that dominant gene that codes for hair. So this genotype is capital H, capital H. Now you have to come here and you have to decide, is that heterozygous or homozygous? Okay, so since both of the alleles are the same, capital H and capital H, I know that they're homozygous. Okay, remember heterozygous just means they're two different alleles. One is capital and one is lowercase. So you can use a text box, but I like my stylus, so I'm going to write it in there. Okay, so I can fill this in right here. This is going to be homozygous. Okay, so now the last thing is phenotype. Remember, phenotype is basically, it is the gene that's actually expressed. Okay, so in this case, it's what the guinea pig looks like. In this case, it's a physical trait. So the phenotype is basically, does it have hair or does it not? In this case, our guinea pig has hair. Okay. On the next one, you have to decide what type of genotype the hairless guinea pig is going to have. Tell me if it is heterozygous or homozygous, and they've already filled in hairless for you. Here, you're supposed to draw a guinea pig, but I understand that may be difficult with Cami. So if you do not want to draw a guinea pig, you can leave this one blank, okay? You just need to fill in the genotype, and here you should be able to figure out what genotype goes here because it tells you that it's heterozygous, okay? And then you have to tell me what the heterozygous genotype, what phenotype that organism would have. Okay, let's look at the next part. Okay, it tells you an allele is a form of a gene. In the Punnett square on the right, how many HH alleles does a baby guinea pig inherit from its mother? So notice here that they're talking about one single guinea pig. Oh, that is not the highlighter. Hang on, let me erase that. Okay. There we go. Okay, so one baby guinea pig, how many alleles does it inherit from the mother? One baby guinea pig, how many alleles does it inherit from the father? Okay, so you're looking for a number there. Well, if you look over here at the Punnett square, each of these are alleles. So what I am going to do, I'm going to fill in half of this and you'll have to fill in the other half on your own. Okay, so remember, you're always going to take one allele from the mother, one allele from the father. So in this case, I'm moving this H down and this H over. So I end up with a homozygous genotype in the first box. So that baby guinea pig would have hair. Okay, so I'm going to move this down. So I'm going to have the uppercase H. Just so you know, the dominant gene that's represented with the uppercase letter always goes first. Okay, and then I'm going to move the lowercase h over. So again, one allele from the mother, one allele from the father, and we have a heterozygous baby. So we have one homozygous baby, one heterozygous baby guinea pig. So now you're going to fill in the rest of the Punnett square on your own and answer those two questions. Okay. Now this one is, if a baby girl guinea pig looks almost identical to its mother, does this mean that it inherited more alleles from its mother? Well, go back to what I just discussed. How many alleles did it get from each parent for this one baby? Okay, remember, each square is a baby, so a baby guinea pig is only getting a certain amount of alleles from mom and from dad. So you have to explain why a baby girl guinea pig might look like mom, even if it got one allele from mom and one allele from dad. Think about the vocabulary words dominant and recessive. You should be using the words dominant and recessive in your answer. Okay, here's your last part. Mysterious Fred, a guinea pig test cross. There is a teacher from Texas that loves hairless guinea pigs. In guinea pigs, the dominant allele H codes for the trait for having hair, and the allele lowercase h codes for the trait of being hairless. Assume Mendelian inheritance. Let's say that this teacher receives her wish of finding a hairless guinea pig at a pet store and names her Genevieve. She finds another guinea pig at a store with hair that she names Fred. So they've already given you a hint here because they tell you Genevieve is a hairless guinea pig. Okay. While she can be certain of Genevieve's genotype, how could she determine what genotype Fred is? She can do a test cross. A test cross involves breeding an organism with a dominant trait, like Fred, because if he has hair, we know that he has the dominant uppercase H, with an organism that exhibits a recessive trait, like Genevieve, because we know she has two lowercase h's. So here we have to write Genevieve has what genotype? Well, going back up here, she is a hairless guinea pig. So she has to have two lowercase h's because that is the recessive gene. Okay, so they're both lowercase. Now, Fred is the one we don't know about. So we want to know, is he homozygous dominant or is he heterozygous dominant? Okay, so that's what you're going to investigate. Okay, over here you're going to investigate the homozygous dominant. Over here you're going to investigate the heterozygous dominant. So they want you to use the Punnett square. I will help you set this one up. This one you have to do on your own. Okay, so remember we need mom. We're going to put her alleles at the top. And then we need dad over here. So we're going to put his alleles. Tells us Fred's alleles right there. And then you have to combine the alleles to make each possible offspring. So here, I'm going to move this uppercase H over and this lowercase h down. So I have one possible combination of genes, one possible genotype for guinea pig offspring. Over here, I can do the same thing. Uppercase H, lowercase h. Okay, so I've got two genotypes filled in to the Punnett square for you. You're going to finish the rest, and then you have to work on this other side by yourself, determining the possible genotypes for the offspring that Genevieve and Fred could produce. Okay, so here's our last two questions. 15 says, explain in your own words how the offspring from the test cross could help determine Fred's genotype. Compare the offspring chances, the possible offspring that could be produced on each side. If you compare those, it'll help you find your answer. Okay. because you're trying to figure out which one Fred is. So looking at the offspring, how can you tell what Fred's genotype is? Okay. And then on the last one, what could be some weaknesses that using a test cross to determine Fred's genotype? What could be some weaknesses with using a test cross to determine Fred's genotype? So when we're talking about weaknesses, what they're wondering is the test, based on the results that you get, based on the offspring that they produce, is it 100% sure? Is it going to show you absolutely what Fred's genotype is? Or is it possible that you could get a misreading based on the offspring? What I told some of my kiddos in class is predicting the offspring is kind of like predicting the weather in Texas. So think about that when you're determining the weaknesses with figuring out Fred's genotype. Okay, if you have any questions on this, always shoot me a comment, let me know, send me an email, and that's it.